In today's lesson, we're going to take a look at inscribed angles and polygons. Let's first start off by talking about an inscribed angle. So an inscribed angle is an angle whose vertex is on the circle and two sides are chords. So let's go ahead and get a visual of that. So I have a circle here. So we're talking about a vertex, which is on the circle, and then we have two sides that are chords, so they will connect to other points that are on that circle. So here would be an example of an inscribed angle. Again, the vertex is on the circle, and then we have two other sides that connect to points on that circle. So AB and BC are going to be chords of that circle. You'll remember back to last time we talked about a central angle where the vertex was at the center, and then we had two rays. This is a little bit different because here our vertex is actually on the circle. Then we also have an intercepted arc, which is the arc that's opposite the inscribed angle. So in this example, arc AC would be our intercepted arc. It's that arc that's opposite our angle. So here we see our angle ABC. We're talking about the arc that's opposite that. So let's talk about the measures of those things and how they're related. So last class we learned about the central angle and how the measure of the arc that's intercepted by it was equal to the measure of that central angle. With an inscribed angle where the vertex is on the exterior of the circle, the measure of the angle is going to be half the measure of its intercepted arc. So this would be 1/2 the measure of arc AB. All right, let's look at an example here. So we have two different things we're going to try to find. We're going to try to find the measure of angle S and the measure of arc RQ. So if I want to find the measure of angle S, we're talking about this angle right here, RST. So we see its intercepted arc, which is arc RT right here, is 60 degrees. We know that the measure of the angle opposite that is going to be half that measure. So the measure of angle S we know is going to be 30 degrees, which is half of 60. If I look for the measure of arc RQ, this one's not going to be quite as obvious at first because we're talking about this arc right here, and we don't really have anything to connect to that. We don't have an intercepted angle that we could actually then find. So what we need to do is we need to kind of break this down and use what we can. So I see that I have 37 here that I haven't used yet. I see the arc that's opposite that. So I do know something about that arc. I know that that arc will be twice the measure of that inscribed angle. So we know that the measure of arc QS is going to be 74 degrees, which is double the 37. You'll then notice that RS is actually a diameter of the circle. So we know that RQ and QS are going to have to total 180 degrees since that's going to form a semicircle. So what we can do then is just subtract the 74 from 180 to get a measure of 106 degrees. All right, let's take a look at the next one. So here we want to find the measure of arc HJ and the measure of angle HGJ, and then we're going to try to see if we can make any connections between the two angles that you see there. So we see that the measure of angle F is 39 degrees. So based on that, I can figure out that the measure of arc HJ would be double that, which is going to be 78 degrees. So that's the first thing that we need to find. And then we want to find the measure of HGJ. So we're talking about this angle right here. Well, if you notice, the intercepted arc, so where those sides are meeting the arc, is going to be the same as what we just looked at with angle F. So we see that HJ is our intercepted arc. We know that the measure of angle G is going to be half that measure. So the measure of angle HGJ is going to be half 78, which is going to be 39 degrees. So then what do we notice? Well, you can see that they both are intersecting the same arc, and so therefore those angles are going to be congruent. So they have different vertexes. However, they do have the same endpoints. So the angles will end up being then congruent. All right, let's go ahead and move over to the back. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. This is what we just figured out. So we're saying that if angle D is congruent to angle C, we're seeing that both of those angles are intercepting our arc here, A and B. So since they're both intercepting the arc at the same point, we know that those angles have to be congruent. So if we're going to look at this figure, we want to name two pairs of congruent angles here. So we're going to kind of use what we just talked about and try to use those intercepted arcs. So if I look at angle Q, I would see that it would intercept my circle at R and S. I also see that angle P is intersecting the circle at R and S. So I know that those two angles would have to be congruent. And then if I look at the other side, well, I see angle S is intercepting my arc, my circle at P and Q. I see that R is also intercepting my arc at P and Q. So I know that those angles must be congruent. So let's take a look at some problems here. We want to find the measure of angle GHJ. So we can see that H, the vertex, is on the circle. We see that we have 2 points, and they're also on the circle. So we know that angle H is a inscribed angle. So we're able to make the connection that it's going to be half the measure of its intercepted arc. Since its intercepted arc right here is 100 degrees, we know that the measure of angle GHJ would have to be half of that, or 50 degrees. If I look for the measure of arc CD in the next one, so we have angle B here, which is intercepting our circle at points C and D. We know that the measure of that must be double the angle that's opposite that, so we know that the measure of arc CD must be 80 degrees. All right, moving right along. So we want to find the measure of angle RTS. So we're looking for this angle right here. Well, we see that angle Q is 31 degrees. So we can figure out that the arc opposite that is going to be double that. So we know that would be 62 degrees. If you notice, angle T is intercepting the circle at the same points as angle Q was. It's intercepting at angle R and angle S, at point R and point S. So we know that angle T would have to be half of that arc measure. So we know that that would also be equal to 31 degrees. And if you notice with this, you really wouldn't even need to find that arc measure RS, because if you can see that angle Q and angle T are intercepting the circle at the same 2 points, we know immediately that those angles are going to be congruent. All right, so now that we talked about inscribed angles, let's talk about inscribed polygons. So an inscribed polygon is going to be very similar to an inscribed angle, except all of the vertices are going to be on the circle. And if all of the vertices are on the circle, we know that all of the sides are going to be chords. So an example of this, if I have a circle here, let's go with the quadrilateral. So I can have points that are all on the circle here, and we see that all of those sides would then be chords of that circle. They're all connecting points that are on the exterior of the circle. So let's learn some things about inscribed polygons. If a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. It must be a diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. So there's some things that we can kind of use here as we start to work through some of these problems, proving either that something might be a diameter or using that to show that we have a right triangle here. So the measure of angle ABC is equal to 90 degrees if and only if, in this case, AC is a diameter of the circle. If you want, you can take a look in your textbook at page 674, example 4. It'll show you how this theorem is actually applied, how it actually happens. So if you're interested in learning a little bit more about that, go ahead and check out your textbook on page 674 to see how that is actually applied. All right, let's go ahead, let's move down. So theorem 1010, a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So we can't just have any quadrilaterals that are inscribed. The opposite angles must be supplementary. So that means that if I look at angle D and angle F, or angle E and angle G, the sums of those angles must be 180 degrees. If they do not total 180 degrees, then there's no way that we could inscribe that quadrilateral. So let's use some of that. So here we have quadrilateral PQRS. See, we have two variables, two angles that we're going to try to find the value of. So we're going to use this directly. We know that if it is inscribed, that angle P and angle R must total 180 degrees. So in order to find angle R, we're just going to take 180, subtract 100 to get a value of 80 degrees. And then to find angle S, I could do it two different ways. Since I know three of the angles in that quadrilateral, I could use the fact that they all add up to 360 and subtract, or I could use the fact that those opposite angles must be supplementary, like we just did. So I know that the measure of angle Q is going to have to be 180 minus 88, which would give us a value of 92 degrees. Let's take a look at B. So B, a little bit more complicated here. We don't have any angle measures at all. They all involve variables. So here we really have to apply, again, what we just talked about. We know that the opposite angles must be supplementary. So we'll go ahead and set up some equations to be able to solve that. I'll look at angle J and L first. So we know that those must be supplementary, meaning that their angles, their measures must add up to 180 degrees. So while we don't know those measures, we do know expressions that represent them, 8x and 4x. We know that they have to total 180 when we add those together. At this point, we can solve this like an equation using our algebra skills. So combining your like terms and then dividing by 12 should get x is equal to 15 for that value. We could certainly check to make sure that that was correct by plugging them in and making sure that angle J and angle L were in fact supplementary. So certainly that's a great way to check to make sure you did your algebra correctly. And then if I take a look, I know that 3y and 3y is going to have to total, again, 180, going to have to be supplementary. If we combine like terms and divide by that coefficient, we find out that y must be 30. Okay, so just using some of those properties in combination with some of our algebra skills to be able to find the measures of those angles. All right, so we have a right triangle that's inscribed in a circle. The radius of the circle is 5.6 centimeters. What is the length of the hypotenuse of the right triangle? So let's go ahead, let's draw a picture here so we can kind of see what's going on. So I have a circle. I know that the radius is 5.6 centimeters. I also know that the right triangle is inscribed in there. So I know that when I draw my triangle, regardless of where it's placed, since it's inscribed and it's a right triangle, we know that it must pass through the center because we know that that side must be a diameter. We know that the radius is 5.6 centimeters. So we know the diameter would be double that, since that would also be 5.6 centimeters. So the diameter, which is in fact the hypotenuse, because that's the side that's opposite the right angle, is going to be 11.2 centimeters. All right, moving on down. Here we have an inscribed quadrilateral ABCD. You want to find the values of A and B. So if we take a look, we're going to use the fact that opposite angles must be supplementary. Well, I know that A and C must be supplementary, so if I look at 5A, and then I know that C is 90, I know that those must total 180. We're going to use our algebra skills here and coming up with an A value of 18. Now, if I look at B, I know that those are going to be supplementary, so angle B and angle D are going to be supplementary. So 4B plus 96 has to be equal to 180. Again, we'll use our algebra skills there to solve that equation and come up with a B value of 21. All right, folks, that's it for our notes for today. You can see your homework down there. Go ahead and do your classwork, and then if you finish that up early, you can get started on your homework. Thanks. Have a great day.